All right. Hi, everyone. How are you? Hopefully, you already have a great break for the afternoon, and welcome to the talk in the first day afternoon of FOSSASIA Summit 2025. So I'm Wendy. I'm a software engineering based in Melbourne, Australia. I'm a volunteer for FOSSASIA Summit in this year. I'm also an open source contributor and a developer advocate. So currently, I'm working in Kubernetes release team. And we are working toward for the newest release version of Kubernetes, version 1.33, which planning to release in this April. So it's my honor to become the MC for the afternoon session today in this room. So for the first talk, for the topic leveraging open source database for strategic advantage, it's my honor to introduce our speaker, that's Peter Farkas. He is the CEO and co-founder of FOSSASIA. He has a lot of experience in leading the distributed team and managing innovative open source projects. He's based in Budapest and he flew to Bangkok today to have the session with us. His favorite ice cream flavor is strawberries. So everyone, please give Peter a warm welcome. So now it's your day.
Hi, everyone. Thanks, Wendy. Honored to be here today, and thank you for the FOSSASIA team for inviting me. This is going to be a 25-minute talk, but it's actually engineered to be 45 minutes. So I'm going to rush through a lot of things here. I also can't see my slides, so I'm going to look and see where we are. But anyway, so my name is Péter Farkas, as Wendy introduced me. I'm from Budapest, Hungary, and I mainly worked at database or data related companies in the past, like Percona or Cloudera, or now FerretDB, which is MongoDB replacement based on Postgres. We are an alternative to MongoDB, and we turn Postgres into a MongoDB compatible database. But today's talk is going to be, well, first of all, what is a strategic advantage? I think we need to talk a bit about that, because otherwise the title of the slide or the talk will not make a lot of sense. So what is a strategic advantage? We will talk about migrations and the importance of choosing wisely. We also have a couple of case studies. I will probably rush through those. And we also will cover how to choose a database wisely in case you are in search for one. So let's start. So what are the drivers of strategic advantage, or what is strategic advantage? Strategic advantage is your edge against your competitors. Who are you? Who are you working at a startup company? Raise your hands. Okay, large corporations, large evil corporations. No hands. Maybe there's some overlap. Just joking. So, so yes, strategic advantage is your edge. Ahead of your competitors. First, you should have a unique value proposition. A unique value proposition is when you have functionality or a service which only you provide to your users. So something which makes you unique from the feature perspective. Second would be cost leadership. This is pretty self-explanatory. When you're cheaper for the specific use case you're providing than any other competitor. Innovation and adaptability. When you're agile enough to make changes on the fly, to introduce new features easily, easier compared to your competitors. And for startups, this is probably your only advantage when it comes to large corporations and competing with them. Brand strength. So you use your technologies based on features, based on how it fits your workload, but really it also strengthens or weakens your brand if you choose wisely or poorly. And what I mean by that is You have a brand you need to protect, and if the underlying technology is unreliable, your users will not like your brand, and that is going to make your life harder when it comes to competition. And operational efficiency. So the technology, and in this case, the database you're choosing, is going to determine how efficient you can be when it comes to your day-to-day operations. If you choose a proprietary vendor with a support subscription and they take ages to respond to your queries, versus if you have an in-house team for open source software or some other arrangement, that can very well make your life easier or harder on our day-to-day operations. On the other hand, if you choose wisely and you're efficient in terms of operations, then you have an edge over your competitors. So in the United States and increasingly in Europe, I'm not sure about Asia in general, there is this thing called storage providers, like physical storage providers, where you have your bicycle or the grandma's couch or whatever else you should get rid of, but you for some reason don't. And then you can just go and take those into a storage facility and store there for a monthly subscription. Usually it's free to move in and your first month is free. And then later on they will charge you per month to store the things which you actually don't really need, but you are afraid to get rid of them. The interesting thing about this is that it's an analogy to cloud-based databases where you get lots of free credits, like let's say you have 250K free credits from AWS or Google or wherever else, and you start storing data in their cloud-based service, and then it's very hard to move out. Why? Because it's already there. So first of all, it's psychological. If you chose a database and your data is there and it works, then you're less inclined to migrate. Migrations are actually pretty hard, not just from a technical perspective, but also because of several other reasons. There's the sunk cost fallacy. Oh, we already paid the solutions architect and the engineers to set ourselves up on the cloud-based solution. That money would be wasted if we would move out. Okay, that's not my slide. But let me move on while this gets fixed. Yes, thank you. So emotional attachment. Many would laugh when they see this slide and this statement that some people are emotionally attached to technologies and databases. Well, you see people in Postgres t-shirts. You see people in MySQL t-shirts. Maybe some crazy people would be wearing Oracle t-shirts. But it's a thing. So it worked for us. We've been working with it for 20 years. Even if something else would make sense, even if our current solution keeps us from having a competitive edge, a strategic advantage, we are not going to change, we are not going to migrate. And migrations are also risky to manage for executive. So imagine the CTO who just joined a large corporation and they have Oracle and it kind of works, they are paying a lot of money, but it's already budgeted for. And who in their right mind as a new CTO would want to manage the database migration project? It's probably the riskiest thing he or she can do, right? So usually these decisions are not just technological, but also a result of risk analysis, psychology, and the like. Trends. So on this slide, you can see that Postgres is overtaking all the other database technologies out there. This is the Stack Exchange Developer Survey of 2023, and Postgres takes the first place, I think, not for the first time in 2023, maybe it was the first in 2022 as well, but it was definitely not the top one database before that. And then we have MySQL, SQLite, MongoDB, and Microsoft SQL Server. So there are some outliers on this graph. You can see that the three databases in the top three positions are all open source. Then there's MongoDB and Microsoft SQL Server, and only one of them is a database which used to be open source, and that is MongoDB. And that's my pet peeve because at FerretDB we are dealing with MongoDB. So apparently users are right and they do the right thing by choosing open source databases. In fact, if you look at the DB engine's popularity trend, you can see that open source databases are on the same ranking in terms of usage as proprietary ones. Now, DB engines have some weird definitions of open source sometimes. Usually, databases which are not open source may make it to the open source category, but nevertheless, the trend is pretty clear. For the last 10 years, open source is catching up with the proprietary. There is this case study. I worked at 4 different companies, and I had the same airline as a customer. And for those 4 or 5 years, they've been trying to get rid of an Oracle-based solution, which showcases that it's indeed very hard to migrate from something which you chose years ago without really looking what you're getting into. There are some details I will not go into because of the lack of time, but as you can see, it took them 4 years to move from Oracle to Postgres and actually have the cost savings they were looking for. So I mentioned cost savings, but it's actually not just about cost saving when you choose open source. So open source tends to be a lot more transparent. You have access to the source code. You can work with people who can provide you the flexibility to introduce features for your specific use case or to better support your specific use case. And it's also community-led, meaning that innovations would very frequently appear in open source first and then move to proprietary, at least in the majority of cases. In terms of transparency, it's a very funny thing, like search for an Oracle database benchmark and you will realize that there's none because actually Oracle license prohibits you from running and publishing a benchmark. So there's that as well. I'm giving a lot of crap to Oracle, but it's actually just for the purpose of comparing. On this slide, I think I mentioned most of things, but the point of this presentation is, okay, we established that open source is the thing. We are sitting on an open source conference. I think we know that open source is great. But still, throughout my career, I've seen people, I've seen customers who chose open source just because there was open source written on it. So it's an open source database. It should be good, right? Well, most of the time, yes, but there is one often overlooked thing, and that is whether it is based on an open standard or not. So there are open source databases out there which are released as open source, but they don't follow any open standard, meaning that it's likely that there's only one provider which exists for that specific specific technology. In that case, open source will not help you to reduce your vendor lock-in risk. So what to look for when you choose an open source database? First of all, the size of the community, I would say that is one very important factor. You look at GitHub, you see that there's activity with releases, you see that there's an engaged community. I would also look for whether the contributors are from the same company or not, because if they are, then it's likely that if that company decreases its support for the open source project, then you will end up with a dead community. License. So I don't want to start a war here. We all have our favorite licenses. Some would say it's AGPL or Apache or MIT or whatever else. I would say the important thing would be to choose an OSI recognized license. BSL, SSPL, and all these things will not give you the same freedoms as proper open source licenses. And there are some other factors as well, like whether you have a choice of different service providers. So is there competition for your business with that technology? If there's only one provider, it's likely that there's none. And you will be paying more for the same service. I mentioned open standards and open source. Who knows what is the difference, or who knew what is the difference between the two? Hands, please. Yes, so open standards are the blueprint. And when it comes to relational databases or SQL, there is a paper which describes how the SQL query language should behave. How should the queries look like? How should the results be returned? And Postgres and SQLite and MySQL and most relational databases would follow that. Now imagine this shiny new database. Again, MongoDB at some point was one of them, or there are some special databases out there for time series or vector or whatever else. Yes, they are very fast. Yes, they are very new. Yes, they are very innovative, but there's no open standard behind them. So there are no standards organizations like the ISO or the W3C, which would actually get vendors together and work on the standard to make sure that the experience would be similar across different alternatives. With SQL, most relational databases would at least give you similar results if you use your knowledge across them on how to query them, on how to build an application for a relational database. In the case of MongoDB, for example, we have alternatives like FerretDB, like Amazon DocumentDB, and some others, but there's no standard, meaning that you have almost zero chance to work across the board. So open standards and not open source is the power behind interoperability, power behind your ability to migrate, and the power behind your freedom of choice. If you only choose your technology based on the license, that will not be enough to save you from trouble. There's actually a full version of this talk. This is just a 25-minute talk. There's a full version of talk where I go over the case study on the history of SQL, on how SQL came to be, on how they came up with the relational concept, how IBM logged in relational database users to their systems. You had to lease one of these washing machine-sized computers to actually be able to use the product. I mean, this looks like an old picture, but you do the same on cloud providers, right? You lease somebody else's machine and you can only use the stuff there. in many situations. So if you liked SQL, you had to use IBM, and then there were alternatives, and then it became a standard, and that was the start of our current world where there are a lot of alternatives for relational databases. And my example is always MongoDB, which started out as open source, had no open standard behind it. Alternatives appeared, and they appear even today, and there's no chance to migrate between these. And you know, this is a history repeats itself kind of situation where MongoDB users did the right thing by choosing an open source database, but ended up dealing with a vendor lock-in when MongoDB changed their license because there were no compatible alternatives out there. And this is my example on how you can choose open source and still get into a vendor lock-in situation. To alleviate this, we started the OpenDocDB initiative where we are working on standardizing MongoDB as an open standard, and we create a similar paper which describes how a MongoDB compatible database should behave. I think these slides will be available, so FerretDB, I'm not going to talk much about it, is an alternative to MongoDB. It's written in Go, it's Apache 2.0, and if you run Postgres, you install FerretDB and you have a MongoDB compatible database. So if you run both, then make sure to check it out. So all in all, as a conclusion, again, we are here on an open source conference. I don't think I have to sell open source to you. I wanted to introduce some other factors which you would need to consider when choosing a database. I hope I was able to provide you some more perspective in doing that. If you were not familiar with the importance of open standards, I invite you to dig into it a bit more. With that, thank you very much for your attention today, and let me know if you have any questions.
Thank you so much for the sharing, Peter. We may have time for the only one concise question. So anyone have any question for the sharing of Peter? Feel free to raise your hand. All right. We really want to say thank you for all the sharing today, Peter. If you guys have any questions related to the talk of Peter and you want to ask him after the presentation, feel free to reach out to Peter anytime when you guys see him around. So now we will have around 1 minute for everyone to move the room and settle down and prepare for the next presentation.
Thank you. Thanks, Fanny.
Auto test.
All right, good afternoon, everyone. Just want to introduce about myself again. I'm Wendy. I'm a software engineering based in Melbourne, Australia. I'm also a volunteer for FOSSASIA 2025. Currently, I work in Kubernetes release team, and we heading to the new version, the newest version of Kubernetes version 1.33 in this April. It's my honor to introduce the next speaker today. We will have the talk with the topic about exploring multiple dimensions of roles with distributed SQL database. And our speaker will be Ridi Kajongbai. He is the senior solution architecture in Bing Caf, specializing in distributed database and distributed storage. And his favorite ice cream flavor is rum rice. It's a very interesting flavor, so you guys can ask him about his favorite ice cream flavor after the talk. So, ladies and gentlemen, please welcome Ridi.
Hello. Yes, thank you, Wendy. So introduce. Sawasdi krap. So this is how we say hello in Thailand. So Sawasdi krap is for men. Sawasdi ka for girls. So you can try it. I hope you have a coffee nice. Okay. All right. So 1st of November 2023, I got a message on my phone that from LinkedIn, right? So everyone expect from LinkedIn, normally it's from notification that someone posts something, right? But in my mind, we looking for the message on the top right that someone ping us for the opportunity for work, right? Yes, and luckily that I have it from Jocelyn, our ping cap or ThaiDB, ping me that, hey, we're gonna have someone in Thailand, we will try to build a Thailand business. So she pinged me that, are you interested in? Right, that one is on 1st of November 2023, right? So yeah, now we're talking, and now I'm here a year ago. And just want to give you that when the recruiter looking for our profiles, it's not just only what is your skill. You're good on Python, you're good on Java, but mostly they're looking for your successor. Like how many projects that you deliver, how many POC or sections you deliver. And also, if you have some sample, it's more concrete that they want to see. So luckily that I have present like this, but in OpenStack a couple years ago. So I put my link on YouTube. And then, yeah, they can see what my style on the stage, right? That how do I strict or how do I funny or how do I present it, right? That they can see what I'm capable of and what it look like. So you may imagine that how many LinkedIn, right? You know LinkedIn, everyone know. But did you know that every 7 minutes, every minute, 7 people get hiring. I'm the one that get hiring as well from LinkedIn, right? Because Jocelyn pinged me. Do you know that in 1 minute, it's around 10,000 people that apply for a job, right? And then this one is 2025. They already have 1.1 billion users in LinkedIn. So you think that how much is big of the data is they have in LinkedIn. So in 2023, Mr. Singh looking for the database that can support their workload. Right? They have their own database, right? They have Espresso, they also have the Oracle and MySQL, right? So he's looking for the new database that can serve their workload at LinkedIn, because it's everyone nowadays looking for the job, post the job in LinkedIn, right? So they already have it. They already have Espresso. They're already using Oracle, MySQL. But the problem is they're using Espresso. They can scale. They like NoSQL, right? But it's not consistency. Right? You know that NoSQL is good for scale, but the problem is it's called eventually consistency, meaning that it's not consistency all across the board, right? So Espresso can serve for the scale, but not consistency. Another hand that they have Oracle, MySQL, is consistency, but it's not easy to scale, right? We have I mean, previous my section, they also have database talking about distributed, right? So it's the same idea that how we're gonna bring to both worlds together, right? So Mr. Singh that telling in the YouTube, you can find in the Google and then checking how LinkedIn evaluate the distributed database, right? TiDB is the one that they choose, but they're looking for the consistency and scalability. That's the key for them, right? How you scale of 1 billion user and also consistency all across the board, right? Let's say I need to post hiring someone, right? I believe that in Indonesia, you should see that my updated. In Malaysia, in Canada, right, or India, should see my updated the information so that it's scale and consistency, right? So he tests multiple databases as well. I don't want to go more detail, but what we impress them, not just only the performance, but on the high availability or resiliency as well, right? Because it's our distributed database that have also protected the data as well. There was a story in Japan, which is they're running on TiDB on AWS, which is 3 AC. One of the AC on AWS in Japan down, right? Normally, if the database, it should be go down as well, and the data should be corrupt. But in that case, one of AWS AC down, but the data is recovery in 18 seconds, I believe. Yeah, 18 seconds, and no data loss. Just resubmit some command, right? So that's the key that we provide into our TiDB. I don't want to go for more detail because I'm pre-sales, not the engineer. But if you want to more detail, we can talk at the booth, right? So yeah, so Mr. Singh that talking about it, how he evaluate. So the two key things that he want to evaluate is consistency and scale, right? And our TiDB that provide both of it, that can scale. We're doing the distributed and using MySQL protocol, right? And then we make sure that all the data that submit into database is consistency. So that is our TiDB. So this is a two project pilot that will link in. We'll be using our TiDB as a pilot. The first one is an enterprise platform, which is integrated with the business that want to integrate the information in LinkedIn that provide professional data to submit or hiring. Another one is marketing that designed for help to audience in LinkedIn to know the company that may be startup or want to marketing or introduce their company in LinkedIn. Right, so this is some of the customer that might know. You guys know like Shopee, Capcom, Bowl, Line, and Trip.com, all of it that using TiDB. And I just want to say that it's not all using only TiDB, right? I believe no application, no company, only one database. But this is the one that they're using us for the mission critical, right? So for example, Line, in Thai we also using Line, not WhatsApp, not Messenger, WeChat. We most is using Line. Line is Messenger, right? So basically he's testing on us, and then he said that it's really easy to scale out and scale in, right? Using just a command to tie up. Today I want to scale for more storage. Using tie up to scale more storage. Today we have more connection like maybe payday like 1111 or 33. We just scale out for TiDB, which is a compute node. Just only one command you can scale out. That's from Line. Bolt, you may have heard about Grab, right? Uber. Bolt is another one that quite popular right now in Thailand as well. So they're running on store the critical application on our TiDB, and you may see that it's around 35K QPS, right? So in Thailand, we also have one of the biggest credit card in Thailand. In the night, there will be a bad job. The transaction of QPS is around 130 QPS that happens every night, which is the one that I taking care of and taking for them. So we see that we can going further a lot of performance, and it's quite linear when you scale out. Another one is Capcom. right? I see someone is quite aged, right? Like me, or someone is still young. You may heard about the games now, Monster Hunter, right? It's quite worldwide. Everyone know it. My kid is also know it. Yeah, this is a new version, right? Monster Hunter. Why? Start using our TiDB to keep all the stats of the games. Keep the item that you bought or monster that you kill. Yeah, everything is on TiDB, right? The key is they're using our TiDB cloud as well, right? The performance expectation. Oh, I forgot to tell you that actually we are the open source. So as of today, you guys can download and then setting up for free, right? And also we also have provide the services and the support from our company. And another one is TiDB Cloud, which is a full managed service. So you don't need to set up by yourself. You just, hey, I want 1 terabyte database, and then it's just created, and it can be scaled out easily. So why I talk TiDB to you? Why TiDB is important to you in this room? 5 minutes, very fast. Okay. Why important to you, right? Because as you can see that a big company using it, LinkedIn, Line, Shopee, Bowl, right? So I believe that you guys should have the skill to have it, right? So that when you update in your LinkedIn profiles, someone that scan in your profile and say, oh, you have TiDB skill, right? So that it create more your opportunity to work, opportunity to have more job opportunity. And we offering the free training. You just go into TiDB and search for training. We give for the training for learn SQL, which is normal SQL. But if you are Java, we also have provide the Java for TiDB that we customize for Java learning. And also we provide the certificate as well. So you can put the badge into LinkedIn that, oh, I have certificate from TiDB. So it's gain more interesting from the recruiter that you have certificate, right? So I believe that everyone have it. So that's why I believe that why it's important to you that you should learn TiDB today, right? That's why you should not catch the trend that happen in the future. I mean, the trend that everyone talking about the distributed database, TiDB is one of it. I don't want you to lose the trend. So that's why. And today, if you're searching for TiDB Cloud, we also offering for free database. Right? It's a serverless, so you can create your own database in Medellin right now. You just sign in using Google, GitHub, or Microsoft. And it's giving for 5 gigabyte for free. You can use it, right? After you register, you got the first cluster databases. We also have a sample to using or testing on like the AI, Next.js or data API. And the last one that I test myself many times is chat to query. So sometimes that I can't think that what is a statement select, form where, filter, right? So sometimes I just, what is the top 10 of revenues? It will be convert from the natural language to SQL for you. And this is a beauty of the serverless that you can try today. And also we have the vector AI as well. So it's a foundation of the AI. So you have a LLM, you have embedded, but at least you need to have foundation, which is a database. So we also provide the vector database as well in the TiDB. So, and last but not least, if you stop by at our booth, right? We have a form, you just scan QR code, put the form. We will print up the NFC name card. You can put in your back of the phone. After that, it will show you the profile, look like here. And yeah, you can add a contract. So you have a business card in NFC card. So yeah, please stop by our booth, just next door. Look for TiDB. All right. I think I'm time's up. If you guys have a lot of questions, please visit our booth. And then thank you. ขอบคุณครับ
Thank a lot for the sharing, Preeti. So, like Preeti said, if you guys have any question, feel free to reach out to him after the talk. So we will have a short break, and the next talk will start in around 2:30. So yeah. Just have a break, everyone, and please come back in around 2:30. Hey, everyone, welcome to the next talk today. Just want to introduce a little bit about myself and Wendy. I am a volunteer for FOSSASIA Summit 2025. I am software engineering based in Melbourne. I also work in the Kubernetes release team at the moment. So for the next talk, we will have the topic Unified Observability, leveraging ClickHouse as a comprehensive telemetry database with our speaker, Ankin Tezuisan. He is a director of services at Antinity. Ankin has over 3 decades of industry experience. He has led the global operation team for MySQL customer and user. He also a well-known speaker at worldwide open source database events, and his favorite ice cream flavor is vanilla and chocolate. So ladies and gentlemen, please give Ankin a warm welcome, and it's your day now.
Thank you for the introduction. Okay. This is a nice introduction on the ice cream. Chocolate and vanilla is nice. So unified observability is our subject today. Thank you for coming, and thank you for the organizers inviting us over here all the way from. I'm from Istanbul, so I flew in halfway around the world. And then the other halfway around the world was last week on a different conference. Let's get connected. If you're not connected with me on the LinkedIn, please do so. There's a QR code, or you can find me on LinkedIn. A little bit about myself. As she said, I'm a director of services at Altinity, and what I do at Altinity is we are a support and services provider for ClickHouse. We also have a managed services provider. We have a DBaaS environment, and I run the support organization for our customers, a lot of customers. And I am an open source database evangelist. I like open source. In my previous life, I worked in large corporations that Peter mentioned earlier in the talks, very, very large companies, and doing very, very large databases using enterprise databases. But recently, I worked in Chista Planet, and all of those are open source databases. At Altinity, we are also open source company. This is an open source conference. We do support for open source ClickHouse. We have a release for open source stable releases, and we contribute back to open source ClickHouse. We also have an engineering team that provides tools like Operator, backup tools, and some other monitoring tools that we provide for our customers, and they're all open source. You can see it on the GitHub. Other than that, I participate in open source events, and I get influential on the database community. Also, I have co-authored 2 books. One of them is MySQL Cookbook. The other one is a design and database design and modeling book for Postgres and MySQL, just recently released. And also, I am part of the Oracle MySQL community as a rock star, and we do actually have events around the world for Oracle events, and that's about myself. And the reality is, sorry, I have to go back over here. I was born to sail and forced to work, and the reality is I'm an avid sailor. I do sail, and I like sailing, so we have to do a real, very fast sailing trivia. The previous talk, the question was, what is the purpose of the boom? So we were asking about the boom. The boom is the, horizontal sprout of the mast. So what is the purpose of a boom? So it's not shown on the sailboat over here. Anyone? Yes, correct. Thank you very much. Okay, we have to go fast. So today's agenda, let's go back to the subject. I usually do database talks, and I'm an expert in databases, but we're going to touch base on observability and database and take a look at that, how we can combine these two. So some of the basics on observability. Introduction to ClickHouse. I think there's a talk after me on ClickHouse, so it's good that I don't have to go into too much deep into that. OpenTelemetry, OTel, is an open source observability tool. We'll talk about that and some of the other comparisons that I'm going to try to run through during this short time frame. So, what are the challenges with the telemetry systems? So the main challenge is we have too many tools for metrics, logs, and everything else that around the traces. So according to Grafana's State of Observability report, minimum number of observability tools deployed in a typical organization. Any guesses? How many tools that you would deploy in generally to have an observability on your systems? Guess? 6. Okay, that's a good one. And this is minimum. And then this makes things very complex and difficult for people who are actually designing these systems. So what are we actually looking into? Matrix traces and logs. So in matrices, basically we see is there a problem? And you're looking at a dashboard, is there a problem? You know, you see, you know, peaks and valleys and then going up and down. There are some traces and where is the problem? And then there are the logs and basically what happened in a given time. So those are the logs. So we all need all of these to have a conclusion on what happened or what's happening in our systems. This is not for only database, this is for the entire ecosystem. It could be, you know, your microservices, it could be your database services or other services that you provide for your customers. Some of these tools you already know, no need to go into that. Grafana is very popular, Kibana and PMM is a database monitoring and management tool by Percona, all open source mostly, and they can be put together as an observability tool in once. So OpenTelemetry project is, if you look at that, to achieve observability, basically on visibility and understanding of your system, you actually connect them to OpenTelemetry collector, and it has the traces of logs and metrics and traces for the backend. So what are we storing over here? We store all these, other than the matrix, we also have the metadata, graphs, topologies, snapshots, and configurations. Basically the whole ecosystem, because if you don't connect the dots, it will not have giving you the big picture. All right, hopefully I'm not going too fast, but I just want to really run through these important slides over here. So we have, we said we have multiple sources, and then we have different sources that connects into a pipeline that goes into a storage. And that's the key part that I want to emphasize over here. It's a challenge, okay. So we have all this data, and then we need to store them, and then we need to be able to use them eventually. So the other systems, we have systems like Prometheus, Victoria Metrics, and other time series databases? Yes, we do. Can we store them in some other OLTP systems like Postgres and MySQL? Yes, we can, but they're not scalable. So that's where ClickHouse comes over here. It shines, and then ClickHouse is SQL compatible, massively scalable, and extremely fast. Really, really fast, because it's a columnar store, unlike the row-based B3 index type systems. It has a columnar vectorized execution, and it makes things very fast for this type of system. So let's take a look at it. What other features it has? Full text search, efficient compression, real-time analytics, relational, and petabyte scale. So when I say efficient compression, do you know what level of compression we can get on a log-based data, for example? It's text, bunch of logs. You can have a very large system. So one of the customers that we were discussing about it, I was saying like, okay, you will get, you know, 50-60% compression. She said, no, we are getting 90% compression on our log data. So this is extremely important that you have this type of compression on a very large and efficient system. Of course, that's also cost efficient. You're not going to pay for the disks. Disks are expensive, and then you don't want to retain them. Going forward, OpenTelemetry and ClickHouse actually pair really well, because OpenTelemetry is a very standard traces and metric logs system that actually is kind of a framework, and ClickHouse gives you a column store on to match with this system. So ClickHouse has an extremely fast ingestion system with the merge tree family of its engine, and it basically takes the input on the data with the index and columns as parts, and then they actually written into bigger parts. While doing that, you actually have the compression, also update and deletes, also rewrite parts, so you have a bunch of parts, and then those parts get merged, and then it becomes a merge tree family of a table. So this table, at the time of this table, you already have some functions that can be built in, aggregate functions, and then you can actually have a very efficient table that is already ingesting data into it. I think we will go into that on the next session. So let's go that, and this allows fast writes. Why we need fast writes on open telemetry like system? Because we're ingesting a lot of data that we may not need at the time, because we don't know what happened, maybe we will visit, or maybe we will not. So it's time friendly, easy to clean up, and cost effective. So we'll look into that, how we achieve that. Basically, we have materialized views, which is very good. Ingesting data, you can actually change into a materialized view. You can actually have your business logic implemented during the ingestion of it. And then there's a TTL. There's no need for purging. It'll expire as soon as you set this one in the beginning of when you create the table for the data that you're storing. It also allows a tiered storage. What does tiered storage allows? Again, on top of a compression, you're actually saving dollars over here. You can have the fast, slower, and the slowest like object store within this system if you set it up right. So these are the considerations that you need to know before you're getting into it. If you actually experimental, it's okay, but if your implementation on a large scale, you might want to consider this factors before setting it up. Later on, it is possible to change these things, but as the systems get larger, operational, you'll be. So there are some other integrations within the ClickHouse ecosystem. Kafka stands out over here, very popular ingestion engine for the data streaming data and the data pipelines. And Kafka engine, using it with the materialized view, is very popular. So that's something you can think. So now we're putting together the dots over here and connecting. So you have Prometheus, Fluently, and eBPF, of course. It's very popular. We'll talk about that a little bit. And then goes into OpenTelemetry collector. So this collector has a direct link to ClickHouse, and it can actually digest all that data into ClickHouse. Okay, more benefits. So we talked about the compression, and you can have an unlimited cardinality, and it actually likes the cardinality and also horizontally scalable. So ClickHouse does support partitioning within a table. It does support sharding. It does also support replication. So basically, depending on the need and the size of the data that you will be storing, you can have all these features already within the ecosystem. Of course, there are some challenges. As everything else, there's no silver bullet. We always say that. SQL is not PromQL. If you're like already have a PromQL environment, and that you need to change into that. But we're always thinking on SQL. Once you're on SQL, you can basically write queries, create dashboards, use other open source tools like Superset, Apache Superset, and create like dashboards. This setup would be very complex for small data sets. You know, if you're not running a large organization, and a lot of this may be overkill. And there's no turnkey solution in this sense, but we'll look into that. And last but not least, OpenTelemetry doesn't have any UI. So you actually don't have a UI that comes with OpenTelemetry. So we have the OpenTelemetry collectors, linked everything back to ClickHouse. You don't have some sort of a administration or management system that comes along with it. Of course, you can have dashboards with Grafana and other tools, but this one doesn't have. So now we have the bigger system that's collected. So OpenTelemetry has other bells and whistles. We don't have time to get into those. You will have application SDKs, collection sampling and processing, and basically that goes into a storage tier. I think we will mention the alerting that can be also configured at the end of this whole pipeline. Let's say you have collected everything, and you can use some other tools like Grafana, environment to do alerting also integrations, or you can actually have APIs that calls PagerDuty and Opsgenie or something like that in that sense. Okay, so now we have come to a point where we have OpenTelemetry, open source, and the framework that comes to collect all the traces, logs, and metrics. And then we have a database called ClickHouse, and then we actually configured for our use case. But this is still basically DIY project at the end. But in this sense, we have a couple of other options over here. Over here on the options, Corroot and Querying stands out. And let's take a look at these real quick to have understanding of it. So Corut is mostly no-code observability platform. It's open source, and it can be configured to run the entire system that includes both application, network, and database operations. And then it can do basically service discovery, linking, and then has a nice UI, will give you the application control plane and monitoring features within the built-in ecosystems. It is using OpenTelemetry and also eBPF tracing, so it allows users to have a much faster start than putting it together as a whole. So you can actually have logs, instances, and CPUs. So it's worth to give it a try in terms of having a solution that's also readily available. So querying is also another tool that comes with a LogQL, PromQL, and TempoQL for OpenTelemetry sources. And it can also use the ClickHouse as a backend in the sense. So I'm no expert on neither of these tools. We've used other tools in our systems, mostly exporters that goes into Grafana, and then we have custom alerts or alert manager integrations in our database systems. But when it comes to whole ecosystem like microservices that includes your application pieces, that may be much more faster start, but having a ClickHouse over here is important because once data is on the ClickHouse, you have better options to query and get to it. Okay. So if we compare the two, we have eBPF-based node agent over here, and whereas querying uses its own collector and exporter. So it's kind of a non-standard compared to eBPF because eBPF is used other places, as you already know. OLTP ingestion via collector gateway. This is something Corut does support, and it has OpenTelemetry exporter schema and needs schema profiles. So there are some differences between the two if we shortlist these tools, and you can check those out and basically come to conclusion. So for the schema considerations, we talked about the compression. So there are multiple compression options in ClickHouse. You can choose, but ZSTD compression is one of them. So we also recommend delta encoding over here. So there are Bloom filters that you can set for the logs. And of course, merge tree family is one of them, is partition on time. Make sure you, like I said, make sure that you partition and set these before you ingesting large sets of data so that you don't run into operational issues later on. And then we recommend 7-day TTL for the large systems, but you can of course keep it or set it up in a tiered storage to keep the data older for the other storages that you can set up maybe slower and cheaper, eventually putting them up to, because of some of the logs needs to be kept longer than 7 days from a security and compliance perspective. So basically that is something you need to consider over here. From the ClickHouse side, we have OpenTelemetry collector over here, and then we have the metadata mapping, and there is a full text search and materialized view that it's come along with this. So these are actually helps this setup complete. And in the querying, you have some other options over here. I think it still uses the ClickHouse features, but it's slightly different than the Corut. So, okay, high availability considerations in the architecture. So let's take a look at it. We actually recommend having a multiple OpenTelemetry collectors deployed so that you don't run into issues with single one. And of course, setting up a ClickHouse as a cluster is advised with replicas. We usually have at least 3 replicas just in case. And then, of course, ClickHouse comes with a keeper, Zookeeper, and ClickHouse Keeper. So we also run at least 3 Zookeeper instances for the metadata. And then we also recommend using Alternity operator for ClickHouse to have operationally scalable environment for the data storage. So the Alternity operator, this open source tool that actually allows PVC management, rolling upgrades, and it comes with the built-in monitoring with the ClickHouse exporter. So little bit on the alerting and other considerations. We have Grafana-based thresholds you can set. You can also have integrations with email, Slack, or PagerDuty, like I mentioned earlier. And I think for the simplified management, this is something we've been researching, and actually there are some other projects in the market that actually uses OpenTelemetry. OpenTelemetry is gaining more popularity in terms of becoming a de facto standard for all these collection of metric logs and traces. So from the cost management side, you can actually have a complete picture with the OpenTelemetry and ClickHouse combined, the two. And that concludes my fast running. I hope I'm still on time. And I have put in the resources. The slides will be available. Links are over here. You can always check these out. And if you have questions, you can ask over here, or you can ping me anytime. Thank you.
Thank you so much for the sharing, Ankin. Yeah, if you guys have any questions, yeah, all right. Yeah, we have one question here.
Hi, I have a question about the table design, and for, let's say you ingest logs for multi-tenant. Do you make a table for each tenant, or do you make a cluster for each tenant using the operator, or what's the way of segregating that you would recommend segregating?
So, so let me repeat the question if I understand correctly. So you're saying, do we need a table for each tenant?
So I guess something I'm missing is, my understanding is that joins are kind of slow in ClickHouse, so people shove everything in one table. Let's say you have data from different tenants that you don't want to mix in the same table. Would you make like one table for each tenant, or would you make one cluster for each tenant?
I would make one cluster for each tenant, in the sense, depending on the design, but it could be the other way. If you partition it by tenant, then you don't need to do that. You can have it in a single cluster, partitioned by tenant, and you can also have an option to do multiple tables. But ClickHouse is not great at joining tables, but it's great at having one large table with denormalized schema design, so you can have multiple columns in it, which is perfectly fine.
Thank you.
All right, thank you so much for your questions.
Do have one more question over there?
Yeah, we need to make it very concise.
Okay.
Thank you for the discussion. Question from my side. ClickHouse supports low cardinality engine for the columns. Does it support low cardinality for the nested maps? For like, you could use it for resources, so you could utilize even less space for the resource column?
That's a good question, but the low cardinality, it doesn't like low cardinality. It likes the higher cardinality in the sense. Is that?
I mean, basically resource is just something which is relatively low cardinality unless you have billions of machines or something like that. And low cardinality is just a string interning to replace strings with integers. So if you would basically do integer maps, you would save a lot of resources to not compress strings even further, just compress integers later with ZSTD.
Yes, you're right. See, I think the way that I take this, OpenTelemetry has a schema that's mapped for ClickHouse. So it is designed to way that it works even for the low cardinality columns that will match to the service that it's tracing. And I'm assuming that the way that it's implemented, that it's efficiently able to trace back to the rows that it's looking for. So I hope that answers your question.
Okay, thanks.
All right, thank you so much for all the questions, everyone. As we run out of time now,
Okay.
so we will have 1 minute break before we move into the next talk. And thanks a lot for the sharing,
Thank you,
Anjin.
everyone.
Hi, everyone. We will start our next session now, so hopefully everyone will have time to settle down and have a short break. So for the next session, it will be another ClickHouse topic. So a little bit introduce about myself. I'm Wendy. I'm a volunteer for FOSSASIA Summit 2025. I'm based in Melbourne, Australia, and I also a Kubernetes release team member. So we work for the newest release version of Kubernetes in this April for the version 1.33. It's my honor to introduce our next speaker. He will talking about a topic for the ClickHouse, immutable database design with ClickHouse, scaling for the future. Our speaker for this talk will be Ibaichans Panopas. He is a technical coach of Arise by Infinitas, and his favorite ice cream flavor is chocolate as well, similar with Ankin. So everyone, please give him a warm welcome. It's your day now.
Hi guys, thank you for joining my section. Today I'm going to share about immutable database design with ClickHouse. Who are use ClickHouse? Oh, so many people. I just have experience for a year. My name is Apaichon Panopat. I'm working at Arise by Infinitas, joint venture between Accenture and Krung Thai Bank. We doing the large payment platform in Thailand. We support 40 million active users and data more than about 500 million per month. My background about full stack developer and data engineer for data warehouse and the big data platform. Okay, let's start. What is ClickHouse? I think many guys at here already know. The ClickHouse is column-oriented database. It's designed for OLAP and its query is very fast. It's designed for query for billion load in a few seconds, but it up to your server spec too. It still use SQL command. I think it's helped to reduce the learning curve for anyone who work with the database. And it support for integration to the many data providers, such as Amazon S3 and Kafka and many kind of the database provider. Who use ClickHouse? For the real-world use case, such as Cloudflare used for handling their data transaction for HTTP analytics, about 5 million records per second. It's helped to reduce the storage cost about $29 million to just 1.9 million. For Uber also jumped to use it too. For they were stacking with Elasticsearch more than 20 server cluster. For their use case, they often to change the log data structure. It might got more performance issue. After they change to use ClickHouse, it can help their performance better 10x. For many use cases to use ClickHouse, you can look at the website of ClickHouse. Have many companies use it. I'm developed the big data project. Still develop. And before I'm select to use the ClickHouse, POC is before. I'm trying to simulate the data same as the real job that I will use. I simulate the data with transfer fund, simulate the transfer the money system. I'm simulate for 100 million record. I'm test on my machine on the MacBook Pro M1. Take the time 25 seconds. When I try to compare with other database that I know, it take more than 30 minutes. This query, query without where condition, I'm scan on off the data. It's so fast for me. Why the ClickHouse faster than other database that I ever used? Many databases keep the data row by row. When you try to query the data, your query might read unnecessarily of column that you not specify to. But for the ClickHouse is column oriented. You can imagine to the map dictionary of any programming language. In each column is separate to different the map object like ID, name, description, or price, something like that. If you select with where condition, you forget only the column, the price column. It will looking to only the column that you specify to. That's why it's not don't take unnecessary performance. The ClickHouse keep data in the granule. The granule like the box set to keep the data. It contains the ID, the metadata, and markup index. It keep the range of value of index, the min, max. This is one key of ClickHouse can predictable that when you select query, which the granule will looking for. That's why it's got the good performance to query. And by default, ClickHouse keep data 8,192 rows. It's up to your configuration. It means that in one granule have about 8,000 rows in that. Unfortunately, ClickHouse have good performance for query and insert, but they recommend to avoid to use update and delete command. Why be like that? In the ClickHouse, when you try to update and delete the data, you must use command alter table. It means that you try to change the data structure. From previously slide, I'm talking about the granule, right? For this example, it's same table. It's column number 1 to 5 and 5 to 10. If I'm try to delete the data, column 1 equal high and column 2 equal to, we'll file the data to column number 2 and column number 9. It means that after you delete 2 records, your granule got the space of 2 rows. And the ClickHouse will merge data to reduce the space. It looks like if you guys ever use the defragment work in the Windows system, it's be like that. If your system have many granules, if you work with big data, your query might affect to the performance issue when you try to delete or update the data. That's why today I will talking about the ClickHouse come with a immutable database design. What is immutable database design? I think who like the functional programming already know. The immutable database design is mean that just insert the data. When you want to update or delete data, you just insert. It sounds crazy, right? But for immutable design have for long time and have many patterns too. For the most popular of immutable design, almost use a temporal validity and event sourcing and snapshot pattern. For temporal validity pattern, it's like you decide to keep the master data. What is the master data? Like the data in this table must have only unique record. Like for this example, for the customer data must have customer 001 only one record, right? When you want to change their name, you must update to that law. But for immutable design, your data can duplicate. If you want to update data, try to avoid to do that. Just append the new record with new information. For the below, the SQL command is another SQL, not for ClickHouse. When I'm trying to implement the immutable design with another database, it's so difficult. It means that when you try to insert many records for temporal validity pattern, you forget to the current state. You must make sure that you update the last record to not current state. It's up to the algorithm that you want to use, and you insert the new record to make sure that it's new state. But for this picture is example, this pattern, many people use the valid form and valid until. This one pattern of immutable database design. For second is event sourcing. Event sourcing who work with the microservice and event-driven architecture, I think like implement like this way. For event sourcing used to the case of you have step-by-step or workflow. For this example, used in e-commerce system, when the customer order create the item add and payment process, it have the event data different data structure. For this second pattern, the last pattern is snapshot. This for use case you would like to keep the data multiple version. For example, in the e-commerce system, your product have multiple attributes for different time. And your system might always change, often change requirement. One day, sell the same product in some price, but in the future might use the own version because we want to discount price or use the past attribute. This snapshot pattern is good for back up the data and reuse the data too for this pattern. when we try to adopt the immutable database design with not natural immutable database, it's so difficult because you must write the complex queries. The main idea of the immutable database design is for avoid the database lock issue. When you work with a distributed system or large data sets have multiple concurrency, if you use the immutable database design concept, the read space never come to read to the write space because you avoid to use the update and delete. If you use update and delete, it might found the issue about database lock is easily done. This is the main concept. For the ClickHouse is have dual view system. This word I'm defined by myself just for describe. For the system mode view, you can see any record that you keep it in the table. But for the application mode view, you can see only record that you expect to. It's up to you select the multi engine. I will show you that the ClickHouse is implement easily than the multi engine have many kind of family. I not describe on. Go is faster. For the replacing multi is used for you can apply to temporal pattern and event sourcing too. When create the database, we use replacing multi. The replacing multi, when insert more data, if you select the data, we will found on the data like this. But if we select with the final, with the keyword final, we will find the record only the last state. It's up to you set the field that you interested that is the newer for your data set. It means that you can keep track on of record and you decide what the data you expect to the user or applications see. For another merge tree engine is use collapsing merge tree. It's different approach from previous merge tree. If your data you would like to delete the data unnecessarily of the state. Sorry. If you forget only the current state, and you want to delete the last record, the way of collapsing merge tree just use fact. For this example, use collapsing merge tree with a side column. If the side column is 1, it means that it seems like active. If you want to delete some record, you must add same data, but change the size is -1. When use the final, you don't see both of record. If you want to update the state, you add the new record. You have T record for when you would like to update. It's the way of immutable of ClickHouse. You just insert the data, but up to you decide that the data you want to see. For immutable database design have pro and con too. It don't mean that it's good for any case. The main point, the benefit, if you not use update and delete command, it can protect you lost the data, but it disadvantage too because you use the space more than the traditional way. And you must avoid to use the ACID concept for full concurrency control. You must think about the eventually consistency. If you want full control ACID, you use another way, not use in the ClickHouse. And ClickHouse, the data can duplicate too. You must know this advantage too. Yeah, before you consider to use ClickHouse, it have good performance for query, and for the update and delete, you should to avoid to do it. Okay. Thank you. Thank you for joining my section. Thank you.
Anyone have any quick question for our speaker? Right.
Thank you, Kap. My question is that is there indexes in ClickHouse? Does it support multiple indexes?
Support for
Indexes for
indexes. Yeah,
for your
it's
table,
support
multiple indexes.
for index too. Almost, I'm not remember, but it have the spread index. It not have multiple kind of index same as another database, but the main index is spread index. You just set the min max value of that column you would like to set to be indexed.
Okay, Kap. Also, does it support caching?
Support
Caching?
caching.
Kap.
Caching, I think for the database, the material view is like cache, but you should to aware that if you use material view for snapshot data, it's similar cache. But in the engine, it had caching also. But if you want to implement cache, it have many ways. It have a memory engine in the ClickHouse too. But for my solution, I'm implement cache with another technology. I'm not include in the database because I would like to separate the resource.
Okay, like moving into Redis or moving
Yeah,
into
something like
Elastic,
that.
something like that. Okay, Kap. Kapuna,
ครับ
Kap.
ผม
All right, thank you so much for the sharing, Abhay John. We
Thank you.
will have our next talk in 3:50, so you guys will have just feel free to have like a quick break for yourself, just like walk around, collect more sticker, continue to reach out into our previous speaker if you still have any questions, and the next talk for this room will be in 3:50. until the left, don't move into the right because the AV recording cannot capture you.
Okay.
So
okay.
don't move into the right a lot, just stay on the left.
Okay.
Yeah, I want to introduce you now.
Okay, sure. And then we pause. Okay.
I'll introduce you now and then digital.
Okay. Sure. Thank you.
Your talk will be 15 minutes.
Okay, sure.
Yeah.
That's fine. I prepare for 15 minutes.
All right.
Okay, sure.
Loading the Q&A. Right. Hi, everyone. We go back now. Sorry for a little bit late. For the next section, it's my pleasure to introduce our next speaker for the topic about automatic database failover at ROS2 data center with open source tool. So it's my honor to introduce our next speaker. It's a BT Champiton. He is a senior consulting engineer at MongoDB with 20 years experience with working with database. Everyone, please give BT a warm welcome. And BT, it's your day now.
Thank you. Okay, thank you. So, okay, sorry to be late. So today I would like to share my experience about how to make automation for failover in terms of any database, but I just focus the two first. Okay, so the first agenda is we talk about the business objective, why we need that when would you have like a two data center, why we need to do like this, and about the open source tool that we will use for automation, recovery the data, and then also the scenario demo that I capture in the slide already, and Q&A. Okay. Okay, so actually why normally I heard that when we have like a business, right, we need like a exact to maintain the business continuity plan. That means one data center is down, we need another center to back up. So and we talk about the database. Normally we have like a one database, and sometimes we need like a database to across of the region or maybe another location, which is help us to like running the business 24/7 day. And then also we need like the objective for the business purpose, we need like a robustness. That means try to make available all the time. That's why we think about how many in terms of the database cluster or database node, more than one place. So that's why we need like the plan how to deploy. And actually what I understand that normally in the official plan, they try to minimize the cost by host the database just maybe 2 data center, at least not more than one. I mean, in terms of the, not talk about the cloud, maybe on the data center, private data center, that means normally we try to make like only maybe at least 2 data centers to do that, which is like a business objective. Why we need like sometime when one data center down, how to recovery automatically another database in another data center will up to make the business continuous again. Okay. That means is right now we talk about the open source tool that I normally use for open source. I think all of you might know already that normally we use the Prometheus to try to log all the data, which is easy for us to do that in terms of the data cluster. Maybe you deploy on cloud or maybe on the Kubernetes. Then I think Prometheus is the one thing that the first choice that we can leverage to use Prometheus to do that, to log the metric of the data. I mean like the metric, like how many usage, how many CPU running, RAM running, we can use the Prometheus. And yeah, because of Prometheus is like a time series, right? So that means you can see like a continuous data in terms of the time series data. Like in every second or maybe every month, it's like keep the timestamp information itself. And also, Prometheus provide the query language that you can retrieve by run query. Is called Prometheus query language. And also, the Prometheus will provide like a pool-based metric, which is just pull, not push from another side. So that means it can like make the timer to pull by set up schedule. And also after we connect the Prometheus try to pull the metric log. After that, we would like to see how to alert us to know that when the data center down or database down, we would like to know that exactly, right? So normally I will use which another open source tool is called Grafana. I think this is like a quite simple set of the tools for monitoring and alert. I think you already know that. So that means Grafana is useful because of a lot of the plugin and extension that you can find from the main website, and then you can import. It's like a JSON format, so you can do like a customize and then multiple data source that you can link to Grafana and then visualize easily. And also include the alert that you can alert and link by maybe like a Slack, Teams, Web API, so you can integrate a lot of the service for your company. Okay, this is the thing that I would like to show you about the scenario. I mean, I know that actually we talk about this open source tool, that how to use open source tool to monitoring the database failover. In this case, I just propose the example use case so you can learn that, and then you can apply for any database, any open source database. And for sure I would like to say that MongoDB is not completely open source database, but this is for the use case only. Okay, so that means, for example, if we talk about the MongoDB, normally we encourage the company to install at least 3 nodes, which is like for high availability. So that means in this case we have like a 2 data center. Why we only 2 data center? Because I asked a lot of people why do you use for like a MongoDB database like this for only 2 data center? Because they said that for optimization cost, which is that makes sense. So that's why. But when you do in the screen like this, you see that building A have a 2 node, right? Which is like a 2 database, and building B have only 1 node. Which is when building A down, maybe outage, you need to provision building B. So that means, for example, if down, right? How to enforce the building B become available again. This is something we can leverage to use the Grafana and Prometheus to automation. So for this case, you know already we have to prepare all the components. This one, Grafana, Prometheus, and the open source tool is like an exporter, which is combine the Prometheus format JSON for Grafana already. So you can use that one. So this is the scenario that I would like to show you, that the step like collect, transform, alert, and action. Okay, so I don't have time too much. So this is like I show you like I capture the screen that normally I use for Prometheus to collect the data, and then we just can download for the website for the Grafana, because Grafana have a free plugin a lot. So for this case, we can download the MongoDB for visualize in Grafana. And then we just set up. This is like a view. You can see how many nodes available. In this case, I highlight on member state that you can see that if primary down, you can the application cannot write at all. So we try to think about when alert member primary is down, we need to do something. So that means in this case, I just use the rule here, and then I just would say that below 1 is mean no primary. Primary is 1, but below 1 is mean no primary. So that means Grafana will alert. And then also, I use the API wrote in Python, which is can collect the alert and then execute to force another building to up and running again if building A is down or outage. So this one like a API. Then this is something that just focus about the in terms of the step of the MongoDB to action. So this is something like a simple code that we try to get the API. That means, for example, if building A down, Grafana will detect building A down, and then Grafana will call the API into Python code, which is I wrote the code already, and then Python code will try to force the building B for the database to up again immediately. So this is in the source code. So this is step that I just captured that this is the step how to make for 2 data center that can handle automatically when one data center is down. We need to force another database to up to serve for the right data, which is this is the solution that might helpful for some people use the Grafana and Prometheus to make automation discovery the data from MongoDB. Okay, yeah, because I don't have time much. So this one, and finally I just tell you that if you would like to interest about the PyCon Thailand in October, you can come again in Thailand for in October. Have like a PyCon Thailand in October. Yeah. So today I don't have time much. So thank you for your time. Yeah.
Yeah, thank you a lot for your sharing, BT. If you guys have any questions related to the sharing of BT, feel free to reach out to him after of our conference. He will be around, so just like feel free to reach out to him and ask him question or connect with him on LinkedIn. Yeah, so now we will have like 1 minute break and we move into the next session in 4:10 p.m. Thanks a lot, everyone. All right, everyone. Hopefully you can settle down for our next talk now. Just want to have a quick introduction about myself. So I'm Wendy. I am a software engineering based in Melbourne. I also a volunteer for FOSSASIA 2025 Summit. Currently, I work in Kubernetes release team, and we try to target to the next release of Kubernetes version 1.33 in the next month in April. So it's my honor, a big honor, to introduce the next speaker for our session today. So we will have the topic about designing YDB, constructing a distributed database management system for OLTP and OLAP from the ground up. And the speaker will be using, he is the principal software engineering at YDB, and his favorite ice cream flavor is chocolate. So ladies and gentlemen, please give him a warm welcome. It's your stay now, Eugene.
Thank you, Wendy. Sawadee Krap. So we are going to speak about distributed systems, about OLTP and OLAP. Again, my name is Eugene, and I am developer at YDB. I'm a really massive fan of distributed systems and databases, and it's best when they are combined together like in YDB. First of all, I would like to make a very important disclaimer. There are many rumors about YDB and Yuga by DB. Some people say we had a bar fight. Other people believe we are exactly the same systems. Also, it's possible to be exactly the same system and have a bar fight, if you remember classic movie. And today is the time for truth. Actually, we are different distributed database management systems. We are both developed by absolutely different companies, by different people. But we are we are friends with Yuga by DB, and we enjoy discussing distributed database systems, benchmarks, etc. So if you are from Yugabyte, hi guys. Well, to the topic. Actually, YDB is not just a distributed database. Actually, it's a platform because we support OLTP, OLAP, even we have Kafka-like persistent queue. Moreover, we have AC transactions between topics and OLTP tables. It really simplifies application development. Besides that, we also have more stuff. You might want to check our website. We have stuff like NBS, Network Block Store, for example. And we are fully open source. That's why we are here. We are a relational database, so we have SQL. And we are a major system. It's 10 years of development. We have huge clusters with thousands of servers. Really petabytes of data. And feel free to start our database on GitHub. We really love, we would really appreciate if you start us on GitHub. We are strictly consistent. In case of partitioning, we choose consistency over availability. So we choose actually CP, which is very important for application development and for important data. We have serializable transactions. It simplifies application development a lot. It makes us mission-critical database for mission-critical data. Consider example. You have a 3 availability zone setup. Availability zone is usually a data center. And one data center might be in fire. Another data center might be partially flooded. And in this case, YDB is still read-write available. And actually, it's not just a theoretical example. It's actually from practice. It might happen. And if you want your database to be available, you should choose distributed solution because otherwise you would lose a lot of money. So we have no downtime for releases because of our architecture, and we work the whole year without maintenance. There is a fun fact about YDB. There are clouds based on YDB. They use YDB for their metadata. And some of these clouds implement their network block store using YDB as well. Network block store, it's analogous to EBS in Amazon. And some of these clouds provide YDB as a service. And that's make YDB bootstrappable. And if you buy this YDB as a service, you get YDB over YDB over YDB. Now, let's jump to main topic and have a quick overview of our functionality. As expected from any relational database, we have tables. Each table has primary key, and data is sorted by its primary key. And we split all the data into ranges by its primary key. We have SQL, we have transactions. Everything is stored in table. And here is a picture showing our architecture. At the bottom, we have distributed storage. And distributed storage is responsible for data replication. For example, it might be pure replication, or it might be some other stuff like, I will talk about it a bit later, like redundancy schemes, like erasure coding. Above, we have tablet layer. Each tablet contains actually user's data. And we have distributed transactions over these tablets. And above, we have, of course, query processing, because we have SQL, we have gRPC layer, and users interact with YDB using our SDK through the network. Today, we are focusing on platform components, distributed storage, and tablets. So let me tell you, but before, let me tell a little bit more about our logical and physical organization. First of all, we have storage and compute completely separate. It allows to scale them completely independently. So you can, depending on your workload, you can scale your storage, or you can scale your compute. In case of storage, it's just distributed storage with few very special tablets. But in case of compute, it contains distributed transactions, query processing, and a lot of other stuff. And if your tablet dies, YDB infrastructure is responsible to restart your compute automatically in proper state. You can easily run YDB anywhere. It can be bare metal, it can be Kubernetes, it can be cloud. So YDB can be run anywhere you need. Typical YDB cluster has shared distributed storage with multiple dedicated databases. So dedicated databases are compute, and compute is separated. And sometimes you would like to share storage between multiple compute because it's more resource efficient. But sometimes you need serverless solution. In this case, single dedicated database is shared between multiple serverless databases. So it's up to you what you actually need. Now it's time to discuss distributed storage. Distributed storage is a very special purpose storage. It's key value storage. Key I will discuss later, and as a value we use blobs. Also because this distributed storage stores blobs, it's historically was called blob storage, and because I'm an old guy, sometimes I call it not distributed storage, but blob storage. I use this interchangeably. And blobs are from 1 byte to 10 megabytes. But it's transparent to users. It's automatically cut into pieces. So distributed storage is dramatically optimized for log. So it's optimized for log records because sometimes, especially in OLTP, you have a lot of transactions and they write data, and each transaction has to write data to be actually serializable. We support multiple redundancy schemes. It might be, if you have single availability zone, it might be erasure coding. In this case, you have redundancy 1.5, which is really cool if you out of disks. So if you don't have too many disks, it's a nice scheme. But if you have 3 availability zones, I mean, it's mostly when your data is very, very important. We have replication, and redundancy is x3. But actually, we support more schemes, and you can easily extend our distributed storage, adding even more schemes. Well, what do I mean by special purpose? Because it's just key value storage, why is it special purpose? Few IP calls are really straightforward, like put and get, but there are few very special ones. There is a call called block, and it's used for distributed consensus. So when, also I can say, you could say that it's for leader election. When tablet wants to become a leader, it uses block IP call to get the quorum from distributed storage. So here we have a consensus. It's similar to multi-paxes. And we have also a very, very special call, collect garbage. We have a barrier-based garbage collection. So tablets are responsible to tell when and how to move this barrier to collect unused blobs. And each distribute node looks like this one. There are devices, and each device is controlled by a single entity called pdisk. We don't have file system between YDB and disks. We control disks on our own because we would like to implement special optimizations. And also we have fair scheduler because above pdisk you have multiple virtual disks. And we would like to control bandwidths allocated to each vdisk. We want a fair scheduling. And usually each pdisk really can have multiple virtual disks. So virtual disk is unreliable component, but we form a group of virtual disks, and each group now is a reliable component and fault-tolerant one. And our distributed or blob storage consists of many such groups. And you can think about distributed storage. I think it's the best way to think about our distributed storage as distributed RAID. Tablets are connected to these blob storage groups. They use these blob storage groups as a reliable storage for their data. And actually, there is a special entity called DS proxy. DS proxy is aware about structure of vdisks. It knows which vdisks it should use, and it's responsible for failure to handle failures of network and virtual disks. So it's for tablet, it's really easy to communicate with virtual disks because there is a special entity and it simplifies life a lot. And API is quite straightforward. Vdisk is actually an active component because there is synchronization between disks of same group. For example, if you get a temporary failure, so for example, your server might be down for some time, it might move somewhere, and when virtual disk is online again, it will go to its neighbors in the group and automatically replicate. Let's look on blob storage group and how reconfiguration might be done. We don't have static configuration, we have dynamic configuration. So if you have some changes in your data center or within your cloud, you can easily move virtual disks from one location to another one. Also, in case of failure, for example, your disk might die. It can be easily damaged. Even modern disks usually die after some time of operating. Recovery can be done fully automatically. So the system is responsible, in this case, YDB is responsible for moving YDB from bad node, from bad disk, to move from bad physical disk. It moves virtual disks to good disks to keep system running. And distributed storage users, they are completely isolated. So you have two levels of isolation. You have isolation on compute level. In this case, no hardware is shared between compute nodes. It's a separate operating system process. But usually they share same distributed storage. They don't share groups. They have different groups. But groups might share same hardware. And depending on your needs, you might set up this because it's resource efficient, or you might want to set another type of installation when you have no hardware shared at all. So it depends on your failure model. Distributed storage is really fault tolerance. Devices can be broken, they can be replaced. We have self-heal, I have mentioned it already, so special process is responsible for healing your cluster. And It's scalable. And because it's completely separated and you have multiple groups, you can easily add more disks, more servers, and you can scale storage completely independently from compute. And we actually have installations with thousands of disks, even more, with thousands of servers, and each server has usually many disks, so it's maybe tens thousands of disks within a cluster. And we checked that our special tablet blob storage controller, it easily handles 10K storage nodes. And each storage node might contain multiple P disks and a lot of V disks. So let's jump to tablets. I'm sorry, it doesn't seem. Okay, YDB tablet is actually, it's stateful, and it's actually reliable stateful building block. So actually it's replicated state machine, RSM. Probably you might know that RSM is usually a part of any distributed system. And tablet is a place where you implement user's logic, like storage or columnar storage. And YDB tablets, they run in compute nodes. Let's look on the picture. Tablet encapsulates user logic like columnar or store, and it has own database implemented over blob storage group. Actually, there is LSM. Usually, LSM is actually what is used with replicated state machine, and it uses blob storage to store two kinds of data. Tablet log, because you need it when you restore tablet on another machine or after a start, and blobs corresponding to log structured merge tree to LSM. And distributed storage provides a really reliable way to store a tablet's data. It's really easy to add new type of tablets. Actually, we don't have just columnar store and row store. We have key value tablet, which is part of our SAM project, and so on. Each tablet has multiple channels. At least it has system channel for its log, and it has channels which depend on the way you use data. For example, you might have SSDs and rotating disks. Rotating disks are slow but cheap, and you would like to store some columns on rotating disks because these columns are rarely used, and you might want to store hot data on SSDs. It's impossible to configure a table in a way that rotating disks are allocated to rarely used columns, and SSDs are allocated to columns which you often use. And finally, let me briefly describe again some tablet types. So data shard, I mentioned it a lot today. It's a row store. It supports SQL transactions. It's ACID, it supports SQL transactions. Transactions are serializable. We have columnar store. It's used for analytical workloads. We have scheme shard. Scheme shard is used to store scheme metadata of your tables. We have a very special system tablet called Hive. Hive is responsible for starting all the tablets for balancing cluster. Actually, if you have questions about balancing, maintaining tablets, we have a core developer of Hive here today. So he's sitting even he's sitting right here in this hall. Feel free to ask questions later. We have coordinators, mediators, because we originally were based on Kelvin IDS, but we seriously extended Kelvin IDS. And we have cluster management systems. Of course, there is a place for configuration. And finally, we have some sort of sysview processor. It contains some statistics. You might want to use it to optimize your transactions. And unfortunately, there is no information on the slide, but as I mentioned, we have topics. It's also a special tablet. And if you are interested in topics, there will be another YDB talk on Friday at 10. It will be about AI, about RAG, topics, streaming, vector search. Feel free to listen to my colleagues about these fascinating topics. So thank you a lot for your attention. There is QR code on our website. Feel free to hit me up with questions now or today or all these days. Our booth is actually located right opposite to the hall number 2. Thank you so much for your attention.
Thank you so much, Eugene. We still have time for 1 to 2 questions. So anyone want to have any question? All right.
I have a small question. I mean, I have many questions.
Let's go outside.
I'm just going to ask one, because I've been working on OLAP multi-cluster applications, and you've mentioned one slide ago something called the transaction allocator. If you scale your system across multiple shards, many nodes, I mean, you're using that, I guess, I'm not familiar with your architecture, so please correct me, to ensure ACID properties across multiple nodes. Don't you have a scalability problem when you use that, depending on the number of nodes you have, because you want to maintain a global visibility of your data, which I guess is repeatable read or read committed, repeatable read or read committed, not serializable. So isn't your transaction allocator potentially a scalability issue? How much do you use a transaction allocator for how many nodes? Or, I mean, isn't it a single point of contention? Or
Thank you very much. That's a very interesting question. First of all, if we speak about OLTP, we have either serializable transactions or transactions which are repeatable read. It's if you can choose between serializable level of isolation, it's by default, and you can use if you want to read from followers, you can get stale read, so it's snapshot isolation, it's repeatable read. In case of serializable isolation, we have multiple coordinators, and we have multiple mediators. So if you definitely, if you have a single coordinator, it might be a bottleneck. But it's possible to shard coordination between multiple entities. And also when you have to send your coordination decision, you might use another level of abstraction called mediators. So we solve the issue of single bottleneck with coordinator by using some special smart sharding of coordination. In case of in OLTP, you also can do scans, but it's not. I think you don't want to use serializable snapshot isolation because you will get locks invalidated if it's really long transaction and you have writes. But you can easily use repeatable read in this case. You can get some stale data, but it will be okay. In case of OLAP, to the extent of my knowledge, it's repeatable read only. OLAP, our OLAP support is not serializable, but at least to the extent of my knowledge. And I don't think there are systems with OLAP workloads which are actually serializable. But if you have many questions, please reach me. Yeah, okay, you can reach me outside. I have also my colleagues, and we can discuss it deeply. That would be nice. But thank you for a very interesting question.
So the applications running on YDB, who has the owners, right? Is it the applications or the database which is giving you the nearest node?
It's up to you. You can run application anywhere. If I understand your question correctly, you have endpoint to your database, and applications use our SDK to connect to the database. We have partial Postgres compatibility, so you can use even PSQL CLI, and it connects to YDB the same way as to Postgres.
you mentioned that the primary keys are used, stored in ranges. How do you store indices? What's the storage for indices?
Well, actually, indices are implemented exactly the same way as regular data, but they are more dense or spare. I don't remember correct word. So indices implemented exactly the same way. It's a tablet, very similar to data shard tablet. And it's up to scheme shard to get information about indices, about shard location, and query processor is responsible for choosing proper shards. So when you have a query involving index, query processing goes to scheme shard. If we don't delve into the details too much, it gets information about sharding of data and about indices. And then it goes to proper shard, which is just same key value table with some structure.
All right. Because we are run out of time now, so really want to say thank you for all the sharing today, Eugene, and thanks a lot for all of the questions from you guys. The next talk will start in about 4:40, so just have time to take a break, and then you can move into another room if you want. We have a few of YDB engineering in our conference. So if you guys still have any questions, feel free to reach out to YDB team. They will really happy to answer all of your questions. Yeah, our next talk will start in 4:40. If it's lighting, what's your favorite ice cream flavor? What's your favorite ice cream flavor?
Ice cream
Flavor.
flavor? Ice cream flavor?
What's your favorite one?
Vanilla.
Vanilla. You guys just have vanilla and chocolate, everyone. Vanilla and chocolate. All talk will be 20, right? We'll start from the 4:40 to end at 5 p.m., including Q&A.
Okay.
Yeah, trying to have let me introduce. All right, ladies and gentlemen, We will have the next talk. It's about the topic MySQL InnoDB cluster best practice. And it's my very honor to introduce our next speaker, one of the amazing speakers we have this event. He's the MySQL Senior Solution Engineering Manager at Oracle. Please give him a warm welcome, everyone.
Okay. Thank you. Thank you, everyone. It's an honor to be able to share MySQL at the FOSSASIA in Bangkok. My name is Ivan Du. I'm from Oracle. I also organized MySQL user group in Taiwan, which was quite active. We have more than 6,000 participants in our group. And this talk is talking about the, I think MySQL high belief been addressed quite a few years. And this is I think the most, I think the number one MySQL HA feature that we are focused on from Oracle, which is InnoDB cluster. Talking about the HA, the policy of HA is just, we don't keep all the eggs within a single basket. So we have many baskets. Once we lost one basket, we can still find the data from another database or another basket. Yeah, but the problem is how can you make sure the data is exactly the same between each instance? Because database is a state for, the database has a state. So how can you make sure that the data will be synced to the rest of the instance timely? This is something that we need to consider. This architecture has been, been there quite a few years since I think since MySQL 4, it's already been there. It's a kind of a single replication, or now we call this the source replica architecture. This is a single replication that we use the database. The application connect to the database, to the master server, or to the source server. And once we issue the transaction will goes into binary log first, and then it will flow into storage engine itself. So binary log will contain all the data, and the rest of the slash server or rest of the replica server. They can configure that your source database is at which host, the port number, and the username that are going to access the database, access the master server, and then issue start replica. Once it start replica, there will be two threads running on the replica server. The first one is the IO thread. IO thread will take the data from the binary log and insert into its relay log. It now will goes into the database directly, but keep in the relay log for the time being. And another set of a thread we call apply thread. We can have multiple apply threads now. So it will help us to improve the performance of the replication. The apply thread will take data from relay log. So once the transaction be issued against the master server, once the transaction move into the storage engine itself, the application can issue the next transaction. So we are at some extreme situation where the master server is very busy. There can be some kind of a lag between the master server and the slave server, or source server and the replica server. So once the master server went down, there's some gap. There's some data still not be able to replicate to the replica server. So once we use this kind of architecture to do failover, from the master server to replica slave server, there might be some data loss. So the improvement is we create kind of a architecture that supports long loss failover, which means that we guarantee all the data will keep into the all the data will be shows on the CLS server or now we call it replica server. The thing is that we come, actually this is not a single product. It's kind of a combination of a three product itself. The core is the group application itself. Cause group application. The group application is kind of a, we used to have a plugin module when we still have 5.7. Now after 5.8, it is come with a database itself. It is already embedded into the database itself. There's a module and each database we call GCM, Group Communication Module. And then we offer a tool, a client tool we call MyShare. MyShare, I think, is a kind of a new generation of MyShare client. It's very powerful. It has many interfaces. It also helps us to access the data with a single command, or with a JavaScript, or with Python. Once you use JavaScript or Python to access the MyShare database, that means you can access data, access MyShare. You can treat MyShare as kind of a document store database, as kind of document store database. There's one interface we call DBA. DBA interface is dedicated for InnoDB cluster. You can use the DBA interface to create cluster, to add a node to the cluster, and do failover and do any kind of operation, backup, something like that. You can use MyShare to do that. Once you do some kind of configuration with MyShare, there were kind of a metadata schema. We call it InnoDB cluster metadata schema created under each node, each MyShare database. And those database can offer, those schema can offer the configuration information of the whole group application. And there's one middle tier we call MyShare router. MyShare router is running between your application server and the database. Your application server do not need to know how many data contained in the cluster, and which node is a primary node. If it is primary node, it is primary mode. If it is a single primary mode, of course, group application can also support multiple primary nodes. The router will dispatch the SQL command from application server to find the right node to return the data and to do the required operations. This is the core of the whole InnoDB cluster. It's a group application. With group application, as I mentioned, that there's a group communication module come with the database. It is already embedded after 8.0, so that means that we don't need to configure the plugin, and of course you can configure the group application without InnoDB cluster, but there's no metadata come with that. If you configure that directly to the group application directly without through MyShare. So there's no way to do some kind of a SQL dispatching or to any kind of auto failover for the group application. So normally I will prefer to use MyShare to do this kind of configuration. Once the application dispatch a SQL command, dispatch any kind of a change against the database, if either it is a single primary node, it is a primary node, or it is multiple primary node. Any node can write, any database can write. There is a kind of enhanced parsing algorithm to make sure that every change will be propagated to the rest of the node when it is failover. Basically, the group application is based on traditional just based on the, traditional synchronization. But with the Parks algorithm, it will help us to guarantee the data will not be lost when we do failover. And the data will automatically synchronize between each node. Automatically synchronize between each node. And once there's a kind of once the node, the primary node is went down, the rest of the node will automatically pick one node as its new primary node. So this is a right failover that can. This is how we can do the failover. And if we configure the groupification with a master share, this kind of change will write into the metadata schema, the InnoDB class metadata schema. So the router will know that. And so this is a way that we can do this kind of almost transparent failover with this kind of architecture. And there's an architecture sit on top of InnoDB class we call InnoDB class set. It is for cross-site replication or cross-class replication. The things that we can configure two more cluster. Each class contains a certain node of the MySQL database into the cluster. Basically, the membership, the number of nodes should be odd number, which means 3. You can have a 3 node, 5 node, 7 node. The maximum number of the node within a groupification is the 9 node, a 9 node cluster. So the minima should be 3. The minima should be 3. So in this architecture shows that there are 2 clusters. Each cluster has 3 nodes, and you can set up with the InnoDB class set. You can specify which class is the primary cluster, and once you configure the MySQL router with the InnoDB class set, the router will know that its configuration. The router will know that there are 6 nodes there, and there are 2 clusters, which class is the primary. And if the transaction is the right transaction, the router will dispatch to the primary cluster, the primary node of the primary cluster. And it will also help you, and the router will also help you to do failover. Once the this primary node is fed, the router will query against the router will query against any kind of any nodes of the cluster to know that there's a configuration change. Because the information is kept on its metadata schema. So the router will know there's configuration change. So the right transaction will dispatch to the next primary to the new primary nodes. And even if it is cross cluster access. For say this is the primary node, and the router, once the router accesses the primary node, once the router sitting on another data center of the cluster, the router will know the change. The router will also do some kind of failover for you. And with this kind of failover, because it's sitting on top of a groupification, so the data will not be lost because we can set and we can also set a replication level. We used to, by default, when we still have at 5.7, the default value is inventory, which means once we do failover, when the failover from the primary to the next primary, there might be some data loss in the first, maybe some kind of data loss in the first few seconds, because the time is needed is to digest the data that not synchronized to the new node yet. But after MISO 8, we set its default consistency level to after primary failover, which means that once the failover happened, the router will pause a while to wait all the data being digested, all the data on the air being digested into the new nodes. Yeah, and once we get a new connection, the data will be, all the changes will be there, or the change there will be no data loss once we do this kind of failover. That is the MISO cluster. And if you want to configure MISO cluster, I think the process should be very easy. The first thing is that we need to specify. For say, if we have a 3 node with our cluster, each server need to be able to access to each other. So the first thing maybe we need to lift the firewall. We need to do the firewall and let the node let the server can see each other. And then the first thing is that we use MISO share. This is MISO command, specified in JavaScript mode. And first is configure instance. This command is to try, this command will do some change against the database and to set up some configuration that the database be able to join the cluster, the InnoDB cluster. And then we can issue create cluster. After we do some change against the database, we can issue a cluster with a MISO share create cluster command, which will create a cluster with only 1 node. And then the next thing is that we can add the instance. We can add instance to the cluster. The thing is to specify the second node, to specify where is the second node. And we can also specify how the second node can synchronize with the primary node. We can use a clone, or we can use manually. If we specify clone, the data will be automatically to copy or clone from the primary node to the new node to the second node. And once we do the add instance twice, we can get a cluster with 3 nodes. And you can also check the status for say this one. Once we add another node, when we issue class status, it will show there's a 2 nodes. And once we do it twice, add the third node to the cluster, the status will show there are 3 nodes in cluster. Which node is the primary, something like that. And the next thing is to configure the router. The first is use MISO router to bootstrap the router and specify any of the node, any node, to create against the metadata schema. And once the bootstrap, we start the router. The router will know that there are 3 nodes within the cluster, which node is the primary node, and then we can configure that. We can get a cluster that help us to do failover with MySQL. And we can also set up the weight. The weight means that which cluster have a more probability to become a primary once we do a cluster select. And we can also do kind of failover, or maybe sometimes we need to do some maintenance. We can control. We can manually to switch over. We can manually switch over from the primary to the secondary, which use the command to switch over. And once the primary is failed, the failover will be automatically happen. The rest of the node will pick 1 node as a new primary, and the router will automatically to to dispatch a request to the new primary because you are doing right. And if the database, if the whole cluster been shut down, and once you bring up, you need to start from total shutdown. You can use the master share to do that. And once the node is done, and you can also once the node have been done, being resumed, you can also specify that you can resume the node. And once there's some, if you do some manual, if you touch the metadata schema, the metadata might not be synchronized. You can also use the scan command to rebuild the schema. And you can also do remove instance, add instance with master share. And sometimes if you experience that you lost most of the node, the whole class will be shut down or either be into a kind of read-only mode. But in that case, you want to let the single node be able to run in to be able to support. You can force the cluster. You can force the class. You can force the Chrome using partition of specify which node is where to take the transaction alone to be able to continue the rest of the transaction. And once the node are being, once the rest of the node being resumed, you can resume the instance. You can resume the instance with the master share. Yeah. So if you want to use InnoDB cluster if you want backup InnoDB cluster, what we can do is use dump instance command. That means that the dump instance will use a Chrome Visual Master Share dump instance command to back up the data, to take the data out, and with a multiple thread. Yeah, basically this is some kind of operation. Yeah. So with Master Share you can also use enterprise backup if you are micro enterprise user. Yeah. So basically this is all about InnoDB cluster that which help us offer us kind of very easy use, very mature, ready to use HA solution for that. Yep, this is my presentation. Thank you very much.
Thank you a lot for a lot of best practice you just sharing for InnoDB events. So sorry that we just run out of time, so we don't have enough of time for the Q&A. But feel free to reach out to Evan and ask him any question after the presentation today. So for the next talk, we will have 1 minute for the break for let our speaker to set up the presentation. Thanks a lot, everyone. Because we have the recording, we have the streaming for our participant in all All right, everyone. We will move into the second last talk of the day. So for the next talk, we will have the topic for the oh no, it's not the MySQL. Oh, it's still MySQL document store. With our speaker is Fasubon. He is the principal MySQL solution engineer, and his favorite ice cream flavor is green tea. So everyone, please give him a round of applause and welcome him on stage.
Thank you. My name is Pasupong. I am the solution engineering from the MySQL team. On my section, I will sharing the wonderful feature of the MySQL. I think the feature of the document store or JSON document, someone don't know this feature before. And I would like to start the Okay. This is my SQL document. I would like to share the JSON data is the one binary inside of the MySQL. Since MySQL version, the 5.7, we include the JSON document inside the MySQL. And then we can working with the JSON standard to working with the, I'm not sure, do you know the MySQL shell, right? When you log into the MySQL shell and switch to the JavaScript, you can just create the JSON schema and working on them. And example, you can working with the JSON script. And then why MySQL JSON is popular because the JSON document is friendly with the developer, and they can quickly develop the new application without the standard schema. We're working with the schema-less, and sometimes working with a web application, it needs to working with the JSON document. And now JSON document is the growth because the JSON is centric of the document for working with the main application. So about the native JSON document, we can working with binary format since version 5.7. And before version 5.7, they're working with the external text, external document. And after we put this technology inside of the MySQL technology, we can improve the performance 10 times of the working with the document outside the database. And in the MySQL database, we have the feature of the validation. When you insert the data inside of the JSON document, we can do validate data. And we have the built-in the JSON function to working with the CRUD, the API. When your application need to working look like same to access with the MongoDB, we can working with the API to access the MySQL database. And the next one, we can optimize, improve performance with the JSON document inside of the MySQL by create the indexing. This is another one can help customer to have to improve the application level. And the last one, this one it should be wonderful feature when you are the DBA and DBA working with the MySQL only, and someone from the developer team need you work with some schema-less with the JSON document. You just working with the MySQL same statement, same SQL statement that you familiar with the MySQL for create the JSON document and maintain it. You don't need to have some knowledge improve for working with another technology for support the JSON. And then almost of it we support them in the MySQL JSON function. And then we can working with the part same structure with the SQL statement in the MySQL for access the data, for extract the data from the JSON document. And then we can generate the column inside of the relational table. When we have the general relational table, we can add on the column with the JSON document for fully managed with both technology inside of the one table. And then you can support index for the improved performance when you have some issue on the application level about the response time of the application. You need to improve some statement, take the time for execute the data. And then the MySQL can working both of the technology inside of the MySQL. And then this is the model of the database for access the database. You can working with a relational database with the statement. When you access the JSON document, you can have the result from the relational model. If the application you need another result for working with the application, you can have another result with the JSON document model as well in same schema list in the JSON document. And then in this picture, this slide, before we have the document store, we need to working with different technology of the database. We have to working with the MySQL one database, and we need to working with another technology for support NoSQL database. Both of them, we need to have the learning curve to take care for operation per day with both of the database, and they need to skill set of the both of the technology. In terms of the MySQL, actually in version 8.0, we can integrate both of them into the MySQL database. One database technology can hybrid technology to store data between the relational and NoSQL application. And the application can connect with both of the statement and the CRUD API to access the JSON document as well. Also, we can work together with the SQL statement, relational table, and JSON document. Normally, in one application, we have the T person included. We have the developer to have the development, the new application technology, and we need to operator after application is a deployment, and we have the management after the application deployment as well. So three of things we can working with the MySQL database. When developer need to develop rapid prototype the new application, and they need to working with the schema list. Also, we can support on the MySQL technology, and we can create a new database for support the developer as well. And after that, when application have the problem with the slow response, we can working with the S-plan to understand the structure of the database, and we can put the indexing for improve the performance of the JSON document for about the performance thing, and the backup thing and restore and replication. We also support with the InnoDB cluster and InnoDB cluster set across the site, and we can work with the MySQL dump for do the backup. Any tool can working with a JSON document inside of the MySQL database. And this is how to access the document use case. This is one of the relational and JSON document to access the database. We have how to access the JSON from the JavaScript, and how to access the JSON document with the query, the normal query. Can mix between the how to access the database between the technology. And then this is the wonderful feature when we need to access the database with the JSON document inside of the MySQL. We can utilize your knowledge to access the database and working with the select ranking some SQL statement. same technology for access the JSON document file, and then you can put some average cost score inside of the data JSON document as well. This is another tool. I think today we have the many application working on the application workflow, and application workflow would like to working with some database access with the REST API. We can working with some we call the VS Code. Now VS Code is popular in the developer now, and the VS Code can put the extension with the master outing, and you can create the master out REST service for access with application workflow with this tool. Okay, this is my slide.
Thank a lot for the talk. Anyone have any question for our speaker? Yeah, so if you guys don't have any questions now, just feel free to reach out to our speaker after the session today and ask any questions. I believe like he will really happy to support you guys. We will have a short break for around like 2 minutes before we move into the last session of today. So yeah, just have a break, everyone.
Okay, thank you very much.
Thanks a lot. Yeah.
Actually, I have another presentation.
Yeah, you have. Oh, you have?
No, I sharing yesterday.
Yeah, after this talk.
Another one.
Yes.
It's not this one.
It's not this one. Yep.
Yeah.
We have. We will have another one. It will happen in around 5:30. So it's just
No,
like.
my presentation.
You?
Yeah, I sharing yesterday. It's different, this one.
Okay. Oh,
This
really?
is my last year
Oh, last year.
at Vietnam.
Oh, really?
I changed. This is I upload when I register to the speaker, right? And yesterday I shared
Uh-huh.
into the new one.
Oh my God. I think like maybe we not update
Yeah,
one.
send
I'm
the
so
long
sorry.
one.
I'm so sorry. Can you just wait a sec to wait for our AV lead back, and then I will ask him to the project for you to like maybe. I just want to
okay.
ensure. I know, but we just want to like ensure that maybe we receive it. Like we have any technical issue, and then we can improve it for the next one. But actually, I really appreciate that you very flexible. You can like. Thank you a lot for that. Our next talk will around 5:30, everyone. So yeah, just take your time.
Okay, I'll put my water in here. Maybe I put my phone away. Relax à? Kêu lại relax à? No. Relax à? Có cho à? I did hả? I did. Too much. Ah. Okay, you like a little bit? You like a little bit? Okay. Ah.
How I can pronounce your name correct? Chinwi or
Chinwi, yes.
Chinwi?
Yes, that's my
Chinwi.
Ong is my last name.
What's your favorite ice cream flavor? Except vanilla, except chocolate. Every speaker love chocolate flavor.
Oh.
You need to have a different one. Which one?
I like pistachio.
Oh, that's a good one. Oh my god. That's a good one. I also love pistachio.
Yes.
Yes, that's a good one. All right. Your talk is 25 minutes, including the Q&A in 25.
Okay.
For the last one.
So my next last one?
Yeah, the next is the last one. Yeah, your data is late again.
Let's hope the speaker is not.
The speaker here.
Yeah, I know.
For the talk just finished, speaker told me like the presentation slide is not correct. It means like he
it was not updated here, and
And he told me like when he showed the slide on stream, he just like he flexible. He just like randomly to reset. Because what's the problem? Why is
this is happening with a lot of people. A lot of people are asking, are their slides the correct ones? I don't know how that happens, but we're going to see if we can help with something about that. So I hope this is the right one. This is the right
one. I think like it's a 13 March 2025. You see, this will be the right one.
Yeah, it is. Yeah, it is the 13th. Yeah.
I'm either like one of the first ones or the last ones. Yeah. Yeah, we have. Hi everyone. Are you guys ready for the closing talk today? So I would like to introduce you a topic that's really interesting and also my current pain point at the moment. That's your data is late again, handling late arriving data in the modern data stock. And we will have a speaker today, it's Ching Wei. She is a senior data engineer at RAV and her favorite ice cream flavor is pistachio. the good ones. So are you ready, Chingui? It's your day now.
Hello, can everyone hear us? Like, can everyone hear me? Loud and clear? Yes, you better be, because your data is late again. Yeah, and it's not a joke. Your data is late again. So about me, thanks for the intro. I currently serve as a senior data engineer at Grab, namely for the Indonesian digital banking use case. I am a speaker and a very occasional writer in my free time in data engineering topics, mainly because you have a lot of pain points when you're working in this field, right? So you gotta write about it. And a little bit about my background, I am 90% self-taught with the 10% from my engineering degrees. But then again, a lot of things are self-taught nowadays because everything in data engineering is self-taught. Well, before we go into the topic, let's set some ground expectations. So whatever insights in this talk are based on my experience and war stories, it doesn't represent my employer in any form. And any coincidence, like any similarity from any real events are purely coincidental, so don't shoot me. And the prerequisite for this talk is that you need to have a sense of the concept of time in data. So anybody doesn't have the prerequisite? Okay, then I shall continue. When we talk about the latest data in the data warehouse or the data lake, which timestamp are we really referring to? Is it when the data even happened? Or is it when the data reached your when the data was updated in the source? Or is it when the data actually reaches your data warehouse or data lake? Tricky question, right? So let's imagine this scenario in your data team, which happens to be an almost everyday occurrence. So you have a data pipeline that ingests data every hour. You have your customer data, you have your transactions data, and your customer data needs to be joined with your transactions data because otherwise, we don't know who made the transactions, right? And we need to know who made those transactions to be able to conduct some transactions monitoring and also to know if there are any bad guys who are exploiting your platform. Well, the bad news is you have an outage. I'm not going to mention what kind of outage, but this outage caused the updated customer data to arrive 3 hours late when your transactions data has already arrived. So, what are you going to do? Are you going to just let those transactions data with the new customers, without the new customer information, flow into your report? Tricky question, right? So your data team's objectives are, number one, you want to ensure timely and accurate reporting for your business users. Otherwise, they're going to be angry. You want to include those late arriving data in your monitoring reports because otherwise they're not going to know any bad guys who onboarded on your platform and are doing some shady money laundering stuff. And because you are sort of in a regulated industry, you also need to maintain audit log of your data changes for data governance purposes. And that's a lot to handle, right? Now, to start off, we need to remember that time is an important dimension in your data. and it's usually not static. It changes over time, and it's not just about your transactions, your attributes can also change over time. And speaking about the concept of time in data, we need to look at a few dimensions. It is not just about one dimension time. For the scope of this talk, we are looking at 2 dimensions. So first dimension is what we commonly know as valid time, also known as the event time or the actual time that the event happened. And this time is mutable depending on which state your data is currently in. Now that's the time that we are used to about the event time. Now we have system time, which is also known as a record time, or we call it transaction time in the database. Not so much about the transaction time in the real world. This is a time where your data for that event is recorded in the system. And this is immutable by default because once it's in the system, it's in the system. And your event time may not be equal to your system time. And did we mention about the modern data stack that we work with? Take a moment to appreciate this picture about our modern data stack. You have your data sources from your databases, your APIs, your S3 buckets, and then you load those data with a data loader into a staging area in your data warehouse. So this pattern is also known as ELT, extract, load, transform, whereby we are extracting and loading the data in the data warehouse before you do some transformation. And then you need to do some you need to do some orchestration, cleaning up, and so on and so forth. And if you look at this data stack, and the time that it takes for the data to flow through every component in the stack, this is where it gets a little bit trickier. So what do we mean by system time? So in the data platform, your system time could be your source system time, your ingestion system time, or it could be your data warehouse or data lake system time. So what system time are we referring to? See the problem now? And if you look at the data stack, there will be data latency in between those steps. And there might be multiple causes that causes your data latency. So it could be your latency in your upstream system, whereby it does take time for your event data to be inserted into your source system. It could be network delays during the ingestion, whereby when you're trying to ingest data from the source system, you face a network communication error. Or it could also be that you have an out-of-order event generation, whereby there's some problem with the insertion of your event data into your database. And this is the sort of challenges that results in us having to deal with change data capture to try to capture all those changes in all your sources, because shit happens. So, what is change data capture, you might ask? Think of it as data versioning for databases. So if you've used Git before, think of it as Git for databases. And this is a design pattern for capturing and tracking changes in data over time from the upstream source, because you want to capture every single event as much as possible so that whatever that is in your data warehouse is in sync with your upstream source. Now, change data capture is not quite new, though let's focus more on change data capture in the modern data stack. We have our modern approaches, such as data snapshots, because storage is cheap, right? Just snapshot all your data. But hey, besides snapshotting all your data, you should also control for performance. So you have incremental models. However, it doesn't mean that your traditional methods are useless, because we still have the concept of slowly changing dimensions, which are still relevant when you're doing your data modeling for change data capture. Now, what are data snapshots? Think of it as taking pictures of your database in very frequent intervals. Let's say every 5 minutes or every hour. Depends on the resolution of your capture. What are incremental models? So to put it simply, we are only taking the incremental load difference between what is already in your target and what it needs to be processed from the source. And then you take the difference. And if you have not seen an incremental model before, typically how an incremental model looks like is that you assume that you already have some data in your destination. You look at what is the latest timestamp in your destination, and then you determine the condition for that incremental load. Okay, now we've talked about the modern approaches. Let's talk about the not so modern approaches, which are still evergreen and relevant. What are slowly changing dimensions? Now because this is not the main subject of the talk, let's briefly run through a recap of what are slowly changing dimensions. The slowly changing dimensions are basically your dimensions data, whereby you want to capture changes in your data over time. For simplicity, let's focus on two main types. We have type 1, which are usually used for fact tables, whereby you take the updated data all the time, and any previous version of the value is overwritten by the latest value. Well, you will have some history loss, but the thing is that, do you want to capture all the history? Oh, if you want to capture all the history, you have type 2 slowly changing dimensions, whereby you implement row versioning for each dimension over time. And when we are going new into type 2 slowly changing dimension, also known as type 2 SCD, there is an important concept called the validity period for each record, whereby you have the effective date, expiration date, and whether the record is currently valid or not. And it's currently implemented using tuple versioning. For those who are not familiar with tuple versioning, here's a quick view of how tuple versioning looks like. Okay, so how does tuple versioning work? Yeah, imagine this is the current state of your data warehouse, and there has been a change in the customer tiering. Now look at the next slide. Now you have a customer whose tiering changed from tier 2 to tier 1, and if you want to capture this change with SCD2, you will need to update the previous record before you insert the next record. And in this case, you are not overwriting the previous record. You are simply updating the previous record. Okay, so now we have gone through all the intro and the prerequisites. Let's go on the meat of the topic. Yes, your data is late again. You are running out of time. You need to do something before your users complain. Okay, take a big breath. You're fine. You're going to be fine because you're here with me. Now, how do we deal with your late data? Let's go into our first layer of defects, preventing the downstream impact from your late arriving data. Okay, so your objective now is you have late arriving data, you don't want it to pollute your database, your data warehouse, you don't want it to pollute your metrics, and then your users will complain. Now, how are you going to do that as the first line of defense? So there are some preventive and proactive approaches that you can adopt to prevent your incomplete data from polluting your downstream reports. So generally, there are two types of approaches that we can do. Number one is doing a data reconciliation approach. And then the second type of pattern is that you can introduce data integrity checkpoints to find out if you have issues with late arriving data. So let's dive deep into those two approaches. Okay. Well, so what's data reconciliation? What's this big word that we are talking about? Okay. To put it simply, it's about comparing data from different sources to ensure three types of metrics. Number one, you want accurate data. And you want those values to be correct, not just in source A, but also in source B. You need your data to be correct. Number two, you need consistency. So what do we mean by consistency? If source A is saying that that customer has $20 in credit, but another transaction, but then you have another database which says that, oh no, this person has $30 in credit. Which one is the correct one? You have a consistency issue. And last but not least, you also need the data to have completeness. Because let's say you have data from source A, whereby you have data all the way until 13th of March, 4 p.m. But you have data from source B, whereby your data is last updated at, what, 10 a.m.? Oh boy, you have a problem. Now, how does a data reconciliation pattern look like? So this is an overview of how it looks like. So you have sources, and you load them into the staging area. And then after you do some raw data processing and cleaning up, you need to define matching criteria. And then compare the discrepancies. And once there is any discrepancies, you need to flag them. And flagging is not enough when you are only simply storing them for your internal use. This is a data source problem. You need to alert your users and your back-end team to do something. And this is where you need to connect your data reconciliation with messaging approaches like Slack alerts or email, because this is urgent. You need them to fix your data so that your users will stop complaining. Well, there are also some things that you can do if you are dealing with this kind of late arriving data streams. So there's this approach that is in the Databricks blog about how you can adopt a streaming reconciliation pattern. So there are three broad steps that you can adopt in a pattern. Number one, identify the late arriving data. So let's say you have late customer data and you have some transactions data already. You identify those transactions data as something that you want to retry later once your customer data is in. So that's the first step. Second step, you have those transaction data. You need to reconcile them, right? So because you keep retrying and retrying, then you're going to have a lot of duplicates in your reconciliation table. So you need to deal with those in a reconciliation table by duplicating and processing them. And after which, You feed those data, transactions data back into a retriable stream to reprocess them once you have more customer data. So you can keep retrying again and again until a certain limit whereby you decide, okay, the customer data is too late, we will have to discard it. Now, second approach is data integrity checks, whereby you can do some proactive checks to detect the arriving data. So you have the refresher integrity to check whether you have those customer IDs in the customer table in the first place. You also have some accepted values because who knows, you have some new values that you don't expect. Or you can also do this approach of, okay, let's just join the whole thing and just submit it even though it's missing. That works too, if you really want to submit it as an interim solution. And about data freshness checks, I mentioned that earlier. You need to have data freshness checks to know whether your data is going stale. Because otherwise, you don't know whether your data has been late for a day. Okay, so how do you implement these data integrity checks? Yeah, to summarize, there are data testing tools and frameworks that you can adopt, such as DBT. Like DBT, they have data tests. You can also use great expectations, or you can just build your own if you have the capacity. And remember that you can have data tests, but you need to remember to schedule them. So you can use schedulers like Airflow, which plays nice with DBT, or you can also use Dexter, which also plays well with DBT and other open source frameworks. And how do we implement those data validation checks and put them together? Okay, let's say you have those sources again. This is your customer data. This is your transaction data. This is, okay, so you have your, okay, this is your transaction data. This is your customer data. Notice something? 1, 2, 3, 4, 5 is not here. So what do? Define your criteria. Define whether so let's say you want to define whether foreign key in table A is available in B. In this case, it's not. So you have two choices. Either you send an alert to the system, which actually you don't have a choice. You should send the alert to the system. But you do have a choice on whether you want to continue the pipeline or not. But hey, this is important. We cannot afford to dirty our target table. So let's stop the pipeline. Okay, then so we go to the, so now we have done those prevention steps. Let's go to the limits of incrementality. Also known as how far can we look back in time. Okay, anyone use DBT? Anyone knows this article? Anyone knows this discussion thread? Okay, for those who are not aware, it's talking about incremental strategy, especially when you're dealing with late arriving data. Firstly, is this table a fact or a dimension? This is something that you need to know first. Number two, when can you expect the late data to arrive? On average, or like most of the time. So based on those two information, you need to determine your look-back window approach to handle your late arriving data. Because you cannot keep looking back, right? You need to set some maximum delay that is allowed before you just ignore it. And why do we need to set this maximum? Because there is this performance versus accuracy trade-off that we need to consider. Wait, so let's first look at the case for a late arriving fax. Example, I have payment transaction that is stuck in pending for more than 3 days. I have a lot of transactions. I have like 10 billion transactions, for example. And it can stay stuck for around 3 days before you have a final status of whether it's successful or failed. Well, it could be more, but on average, 3 days. So the design question we need to consider are, do we choose accuracy or do we choose performance? If you choose accuracy, which you might if you have small data sets, then you need to scan a wider date range, right? Because who knows, your payment may take 90 days to resolve, or maybe a year. Okay, if it takes a year, please don't use that vendor. Okay, so let's assume that you want to choose performance. But the thing is, you cannot have performance and accuracy at the same time, right? So there's a small possibility that you may have some late data loss from data which is very, very late. So how do we implement this type of pattern or for late arriving facts? Pretty simple. You implement a look-back window of a maximum of, let's say, a certain acceptable window. It could be 3 days, it could be 5 days, it could be 7 days, depending on the distribution of how late your data arrives. Maybe take it as a 95th percentile, 97th percentile. Yeah, but your mileage may vary. Okay, the facts part is easy. But what if your dimension data is late? This is fine. You're with me, you know what to do. Now, the case is that your customer information data is late, and those are new customers. And the problem is that you have 5,000 customers that are impacted out of your 3 million records. Good luck. And you need to join both sets of data, your transactions and customer data, for your transaction reporting, because you don't want the bad guys to get away with it. So the design question in this case for dimensions is a little trickier. So if you are using slowly changing dimensions, especially your SCD2, which dimensions, so which time should we use? You want to use valid time or you want to use system time? You use valid time, then you need to hope that your system time is quite close to your event time. Because if your system time is much, much later than your event time, you will need to deal with a longer look-back window. That means you need to scan more data, which is more expensive. But let's say if you want to use system time, right? That's not great, right? Well, then you have a problem because your system time is not equal to event time. And if you do system time, it's not capturing real-world events either. So what do we do? So how do we handle late arriving data in this case? This is where we might need to do some custom incremental logic, because we also want to have those late arriving customer data to be included. So the design objective is that you want it to be performant and you want it to be close enough. So that's where you need to have some form of an event look-back window for both your transactions and your dimensions, your customer dimensions, so that you can also handle your early arriving facts and also your late arriving dimensions. And you need to do them incrementally. So if you look at this example, you notice that there is this change. So previously, it was mainly on the facts. Now you also add another filter to handle those late arriving dimensions. And you notice that we have some threshold window. So beyond that, we don't care. The time has already passed. But what if we want accurate data? We want it eventually accurate. Solution. Just do a periodic batch job. Let it run through midnight. Just let it run in the background. Problem solved. Okay, so far we are assuming that we don't really need to rewind. But what if we really need to rewind history on the data like your history on your data warehouse? It means I want the event time, I also want the system time. Imagine this scenario. You have audit once data, that you have reported somewhere in the past. But then somewhere in the past, there was some issue with your data and you had to do some correction, but they are asking for data prior to the correction. So what do? Yeah, so this is the kind of scenario you have. You have some wrong data, then you need to deal with it. But you need to report what you have, you need to report the raw data you have reported. So how do we do that? This is where you need to deal with bitemporal models, unfortunately. So for those who are new to bitemporal, you are looking at both the valid time and system time, and you want to capture any retroactive changes in data over time. So the objective is to preserve your history, regardless of what happens in your event and in your system. So the objective is mainly for data governance purposes. So some implementations of bitemporal models, because that's not the main bulk of the talk, but you can look up on bitemporality if you're interested. So that you can do data snapshots of tuple versioning models, which we have mentioned earlier. You could do some history table for tracking state changes with system time partitioning. Or you could use change data capture and just keep capturing all those DML changes and then figure out how you're going to deal with it. And now we have gone through some of the techniques and approaches on how we can handle late arriving data. Here are some key takeaways. Number one, about late arriving data, we need to be proactive, not reactive. Hence, what I'd like you to take away from this talk is that we need to design proactive systems and models that can handle late arriving data to ensure data quality. And last but not least, we also need to manage accuracy versus performance trade-offs with window thresholds and also make up on the accuracy with periodic batch jobs. Because sometimes you may not be able to get accuracy now. You may be able to get accuracy later, but the most important thing that we need to do is impact, business impact. And even if your data is very accurate, if it does not provide impact, or if it does not provide impact, and you spend so much time on trying to make it accurate while it suffers in performance, you are not going to have a job, right? And ultimately, if your data is late again, and you are running out and you don't have a lot of money, which is currently the case in a lot of places, prioritize performance first. The accuracy can always come later. Thank you so much.
Are there any last question for Chingui for this interesting topic? Right.
Here are the slides. And here are the slides. And if you'd like to connect with me, here are my social media links.
Yeah. Hi, Chingui. Don't some tools like Snowflake or Databricks take care of the bitemporal because they do the auditing and they give you the history? But then my question here is, I guess if your data comes in late, even if you got that history and you try to go back in time for a snapshot on a certain, let's say, 1st of July, you're actually still missing the source record, right? So kind of, I guess the problem is still there intrinsically that you need to resolve the data kind of ingestion part. Is that my takeaway?
The main takeaway is that okay, you want accurate data, but you also want it to be performant, and you want to be able to fulfill your objective of delivering your business with insights, business insights. So I think the trade-off is, so the thing is that you need to balance, like, when do you want to value accuracy and when do you want to value performance?
Yeah.
And yes, I use Snowflake, so I am aware of the time travel, although it's up to 90 days, but it's good enough for most cases. I think eventually, like, it really depends on the industry.
Okay.
But in the financial industry, where you have some regulations and you also have like audit requirements, that's where they will expect some form of data governance and some audit logs. That means even if your data is wrong and you have to submit that as an interim, eventually the audit will still want to know like what have you submitted to the regulators.
I see. And so the tools, I mean, the tools, even if the tools get better, they're not necessarily going to solve for these operational issues which you've highlighted here, huh?
Yes, unfortunately, no matter how modern your modern data stack is, your business problems are still going to be evergreen.
Thanks a lot for the very insightful and informative closing talk, Jingwei.
Thank you.
Yeah, we really appreciate your time. And thanks a lot for everyone for spending time with us for the first day of FOSSASIA Summit 2025. So this is the closing for today already. Hopefully you guys will have a great night today, and also hopefully you will have a great experience today. You learn a lot of new things, you met new people, have a new connection, and I hope to see all of you guys again tomorrow for the second days of FOSSASIA Summit 2025. Right, thanks everyone.